Hello, welcome to the lecture of engineering mechanics. In this video, we'll cover the chapter friction. It's a quite interesting chapter. So these are the outlines we'll be covering in this video. The first thing we'll see the terms related to friction. Then we'll see the laws. Then how to check the state of any object. Then we'll see the limiting friction value. Then we'll see the range of the friction force, and then we'll see the graph how the friction force is varying. Then we'll see angle of friction, angle of repose, and then the sliding versus top line. And at last we'll see the application of the friction, belt friction and ladder friction. Then we'll do a lot of numerical, then wind up this session. Okay, let's start. So before that, what is it? Before going to the specific topic, we should know what is friction actually means. See, if I will take two lines, okay, just I'm taking two lines. Suppose these lines are placed very close to each other, okay, that means they are in contact. So whenever you will try to make relative motion between them, suppose I'm making this one is raised, okay, this is the ground suppose, and the upper one is the surface. Whenever there is a relative motion between them, there will be resistance. Why? See, any surface you take, any surface, whether it's smooth or rough, there is always in the microscopic level there is up down. That means the surface irregularities is there in any surface. There is no surface which is 100% smooth, okay, there is always roughness. Why we say there is the surface can be a rough surface or a smooth surface? Because see, it cannot be 100% smooth, but for our eyes, human eyes, we can see we relatively there some surfaces are smooth and others are rough. In that case, it's depend upon the amount of irregularities. Okay, so smooth surface also rough. Okay, whenever these two surfaces are in contact, if I'll draw the ground again, the reality of this surface, if in the microscopic level I will see this is like this, up down like this, okay, and the upper surface like this surface also have this irregularities in it. Okay, what will happen, this is the microscopic structure. Okay, I'm talking about microscopic structure. Whenever you try to make relative motion, what will happen, there will be interlocking. Okay, since interlocking is happening, what will happen, there will be resistance to the motion. Okay, that's called actually friction. Okay, so can you see there is a car which is going uphill in an inclined road. Okay, in this situation, if there is not sufficient friction in the tire portion, what will happen, there will be slippage of the tire. Okay, the vehicle will not go up smoothly. Okay, so there are things where friction is required, and there are some special incidents where we are, our aim is to reduce that friction. Okay, so what it is a friction? Okay, so friction is something which is opposing the relative motion, okay, between two surface. See, whenever you want to move, okay, whether it is your in your daily life or anywhere, there will be some obstacles. Okay, see, this is the solid surface, the number one up surface of, and the down ground was 2. The between these two, whenever relative motion, there is friction. If you talk about the between the layers of fluid, this resistance is called viscosity. And whenever there is a solid object and fluid is flowing, the drag, that's called drag, the resistance of the object whenever there is contact between the solid surface and the fluid. This is called drag force. That is also a resistance. Here in fluid, it's called viscosity. In solid contact, that's called friction. Okay. Whenever you will try to make relative motion, there will be resistance. Okay. Now I want to ask you why there is relative motion, because we do some work. See, the ground surface 2 is already there. For the relative motion, I am applying some amount of force so that the surface will displace so that we can do some work. And what friction is doing? Friction what is doing? It is consuming that work. So it is consume work. Okay. Consume the work. So is it good thing or bad thing? If we are doing some work for a specific purpose, but what are happening? The friction is consuming that amount of work. Whether it is good or bad, it's depend upon the situation. In this situation, we need friction for going up. And if you talk about in the gears of the vehicle, if you talk about the engine, in that gear are there. Okay, you have see these are like gears. Okay, in this gear set, whenever there is relative contact between them, relative motion happening between two gears, like another gear is there, in that case we want to reduce the friction, but here we want an extra amount of friction. If you talk about a pulley belt drive, okay, in a rice mill you can see there is a motor which is operating by the electrical energy, and the rotational effect is being transferred by the belt to all the other by using some belt drive principle. Okay, we'll discuss the belt drive, but in that case the friction is required. Okay, friction is required. Here friction, we want to minimize the friction, here we need friction. So there are different situation where we want more friction, and there are some situation where we want to reduce the friction. Okay, so it is a necessary devil. It is consuming our useful work, but still it is necessity. Because see, if the there is no friction, then the existence will not happen. Okay, why I'm saying, if I want to walk from a position to another position, in my foot there must be a friction, or if there is a reduction in friction, if in between the floor and my foot, if there is a oily liquid, so friction reduced, because the whatever the irregularity is here, whatever the irregularities is there in the surface, okay, if that irregularities got filled by the oil and I'm trying to go walk on this surface, what will happen? There is no interlocking, so there is a reduction in friction. So what will happen? Slip will happen, so I cannot move properly. Okay, so friction is very necessary. Now I think you got what is friction. So now we'll proceed to the topics. So see, what are the terms related to friction? Okay, we'll see one by one. So the first thing I'm saying, normal reaction. What is normal reaction? See, the third law of Newton's, to every action there is an equal and opposite reaction. Okay, whenever you apply any amount of force, there will be a reaction force. So I'm talking about normal reaction. Okay, I will apply force, I will get reaction. What is normal force? See, here if I will take an ground, okay, this is the ground and I'm taking a block. Okay, there is this block is placed over this one. What will happen? Here as you can see, there is a weight by the block on the ground. So what will happen? The ground will give another reaction force. This was the weight, but the ground will give an reaction force to the block. That will be the reaction, normal reaction N. Why I'm saying it's normal? Because weight in the downward direction and the normal reaction is, these two will balance each other. Okay, in that situation, this reaction called normal reaction, it is perpendicular to the contact surface. Here is the contact surface. Okay, the normal reaction is perpendicular to the contact surface. That's why it's called normal reaction. Getting my point? Whenever there will be physical contact, the reaction given by the ground on the object which is perpendicular to the contact surface. So whether, suppose there is a surface like this, okay, but you have an object like this. In that case, this is, suppose this is the contact area. Okay, this portion is the contact area. What will happen? The surface will give, you see, this is the weight will come. Okay, this is the inclined surface. Okay, I'm getting, suppose this is the angle theta. What will happen? This angle will be also theta. Why am I saying? If you draw like this, here is the surface. Okay, this is the theta. If this is the theta, if I'll draw another line perpendicular to this line, okay, these two lines are perpendicular. In that case, if this theta, it's 90 minus theta. Here again will be theta. Okay, you can calculate by trigonometry. So this angle is theta, so it is W, it will be W cos theta. So the normal reaction, this will be the normal reaction. This is the applied force on the ground by the block. What you will get? You will get a normal reaction by the ground to the block in the normal direction. Okay, so perpendicular to the contact surface. Here is the contact surface. So perpendicular to the contact surface, you will get a reaction force whenever there is physical contact. Okay, that's called normal reaction. I think that you got the concept of what is normal reaction. Okay, normal reaction, I will write, it's perpendicular to the contact surface. Okay, now the second term which will be used in friction most likely, that's called force in the direction of possible motion. What it is? See, we'll take an example. Suppose this is a block. Okay, and again I'm taking an ground. Okay, this is the ground and a block is placed over it. So suppose the weight is W. I'm writing the normal reaction here. Okay, I can write this normal reaction as well in the upward direction. I'm writing here because the force can slide along its line of action. This is the normal reaction. Okay, so in this situation, you got the weight, due to that you got a normal reaction. Okay, now if I'll apply an amount of force, suppose I'm applying a force like this. This is the force. Okay, what will happen? This force will try to make the motion in which direction? If it is in x direction, the motion will be also, the acceleration you will get also in the x direction. So you will get the motion along the contact surface. Okay, in this surface you will get the motion. Suppose another case I'll take. This is the ground. Okay, there is a block. Okay, no issue at all. Here is the weight. Here is the normal reaction you are getting. Suppose the force in this block is like this, certain angle. This is the force P. Is this the force I'm talking about, force in the direction of possible motion? No, the block will move along the ground only. Okay, so the component of the force in the direction of the acceleration, that is the direction of the motion. Okay, so this component of this force, this, if it is theta, it will be P cos theta. This is the force I'm talking about. This force, that means the force in the direction of possible motion. Okay, due to the force, the amount of force due to which the motion will be possible in the direction. Okay, whatever direction the motion is possible, in that direction what amount of force is acting on that object. So this is clear. Then we will talk about coefficient of the third thing. Okay, third thing, it's called coefficient of friction. Okay, see, it's a it depends upon the nature of the surface. Okay, suppose I will write this coefficient of friction can be classified into two, mu s, then it's called mu subscript k. It's called static coefficient of friction, this one called kinetic, or we can say dynamic coefficient of friction. What is coefficient of friction? See, every surface has some irregularities. Depending upon the surface, we have a specific value of coefficient of friction for that surface. Okay, depending upon the irregularities. So this is the property of the surface. You will get from the surface, which surface you are dealing, that there will be given a coefficient of friction in any problem. Okay, again if I'll try to give the classification, see, this is the engineering mechanics. Okay, here engineering mechanics can be classified into statics, again to dynamics. Dynamics means the object is in motion, statics means the object is not in motion. Okay, that means it is in equilibrium. Okay, equilibrium. Here dynamics can be classified into kinematics and kinetics. See, here the motion is possible. Motion is possible means there is some amount of force is acting on this. Okay, there is some force. Force is there. But if I'm not considering the force, I'm just study of the motion. Any object you have, you are studying the motion, like velocity, acceleration, displacement, all these things you are discussing. This is called study of motion. These are the parameters to study the motion, and you are not concerning about the force. Okay, if you talking about force, then it's called kinetics, the study of motion. Here also you will talk about velocity, acceleration, surface, but such that the force is considered. Okay, the force is considered. So in the short question, MCQ type question, it will ask mu, the coefficient of friction, whether it's kinetic or kinematic. You will see it's kinetic because we are in the friction chapter. We are going to deal with some amount of the force. It's static, but the object is in equilibrium or in motion. The object, we are applying some amount of force. Okay, so that kinetic, there will be possible relative motion, and the friction will resist that relative motion. So friction is a force. So it's kinetic, we are considering the force, or we can say dynamic. Okay, you cannot say it's a kinematic coefficient of friction. Okay, so that's why it's called kinetic mu, or we can say dynamic coefficient of friction, dynamic. Okay, you got the idea. Whatever topics we are covering, like fundamental of engineering mechanics, then we discussed equilibrium, truss, and here is the friction and some application of the friction like simple machine. We'll discuss in the next video. These are the part of the statics. The object is not moving at all. In the dynamics, we'll talk about rectilinear motion, that is kinematics. Then we will talk about in the kinetics in the rectilinear motion, that means the object is moving in a in a straight line. In that, if you are considering the force, it's called kinetics. In that motion, if you are not considering about the force and you are studying the motion, that's called kinematics. These are the classification. Okay. So in that case, the coefficient of friction is this mu s mu k. This is unitless. Okay. I'll write like this. No unit. This one, also this one. Okay. No in. This is the third thing. We need to discuss one more thing. What it is? It's called, okay. Okay. Here I'm writing the fourth one. What it is? I'll use again. It's called frictional force. Okay. Frictional force. It is represented by like this small f. Okay. So what it is? Here we again have static frictional force, kinetic frictional force. Okay, or dynamic frictional force. Okay. What is frictional force? We'll see. Okay, there is a law to define the frictional force. Okay, that's called law of dry friction. Okay, in the whole chapter we are going to calculate this friction force or coefficient of friction only, and we understand the concept of normal reaction. What is the normal reaction? Okay, normal reaction and the force in the direction of possible motion, because motion will be always along the path. See, I'm writing here, whether it's any motion, circular, in the dynamics we will see. I'll writing in a point, motion is always along the contact surface. That means it is tangent to the contact surface. If the surface is straight, the object will move in that path only. Okay. So we'll go to the next. Here the classification of engineering mechanics. Now I'm talking about the law. Okay. What is law? See, all the three topics, three terms I have discussed, but law I have not discussed. Okay. After discussing the law, I will give another coefficient of friction. Don't worry about that. So I'm writing some statement for the law. Okay. Just see carefully. Frictional force. What will happen to the frictional force? Frictional force is the force which opposes the relative motion we have discussed in the start of the session. Relative motion. This is very important statement. There are a lot of numerical can be solved with this statement only. Don't take it lightly. It opposes, what it is opposing? It's opposing the relative motion. Okay. Now I'll write the second statement. What it is saying? The frictional force act along the tangential direction to the contact surface. So I'm writing frictional force we have seen all these things. Frictional force act. This thing I have not shown you. I have shown you the force in the direction of possible motion. Okay. So frictional force acts tangential. I'll write the term tangential in different color. Okay. Tangential. This is the most important thing. MCQ will ask from here on. Frictional force act tangential to the contact surface. Again, the third statement of this law is saying the total frictional force, develops is independent of contact area. This is important for MCQ. Okay, the frictional force develops is independent of contact area. What it is, I will discuss. Don't worry. The number fourth statement, the maximum, it's talking about the value of the frictional force. Okay, the maximum friction in static, whenever the object is in static condition, the amount of force, the maximum amount of frictional force, or we can say this is also called the limiting friction force, is defined like this: Fs maximum is equal to mu s into n. Okay, so this is the, okay, Fs maximum is equal to mu s into n, the value of the maximum frictional force. Now we'll talk about the fifth statement. What it is saying, it's saying the force required to sliding is greater than the force required to maintain sliding. What it is, we'll see. Force required to start sliding, that means he's talking about to make the sliding motion, the amount of force required is greater than what? Greater than the force required for maintaining sliding. He's talking about the force, the initial amount of force to make the motion, it's more, the amount of force required is more than once the motion is started. He's talking about there will be less amount of force will be required. Okay, now we'll try to understand all these statements. See what it is saying. It's saying the frictional force opposes the relative motion. This is the statement we have already seen in the starting of this video. Is saying the frictional force acts tangential to the contact surface. See, in the initial statement where I was saying about the force in the direction of possible motion. This possible motion in the direction of motion means this force was along the contact surface. Okay, this force, I was talking about the force in the direction of possible motion. Now he's talking about the force, the frictional force. He's not talking about that force. He's talking about the frictional force acts tangential to the contact surface. That means it is also acting tangential to the contact surface like that force. So it is also collinear to that force. Getting my point? That force was tangential to the contact surface. This force also tangential to the contact surface. So this is also collinear to that force. Okay. What is frictional force? We'll see. What is the direction of that? We'll see. The direction is nothing but it's opposes the relative motion. Okay, and it acts tangential to the contact surface. You got it. Now he's saying the total frictional force, the amount of frictional force will develop in an object due to the relative motion creation. It is not depending upon the contact area. It's not depending upon the contact area. This is very important as far as MCQ is concerned. Okay, so it's independent of contact area. What it is saying, see, it's saying whether you take like this, I'm taking this is as a block or a small block, it doesn't matter. Okay, he's saying here is the contact area. See, in the first case there is a big contact area. Okay, here is a small contact area. the contact area you are seeing as a line, but in actual there is, in 3D there is a like a area, okay, rectangular area. So he's saying the A1, here is the area A1, here is the area A2. In these two cases, he's saying the frictional force, whatever frictional force will be developed is independent of this area, whether the body is having a big contact area or small contact area, it does not matter. It's matter what? It's matter about, if the weight are same, then it does not matter what amount of area, contact area it have, okay, it's independent of the contact area. You should remember this one. Then in the next he's saying the maximum frictional force in the static, the maximum friction in the static, in a static, whenever the object in the equilibrium condition, it is not in motion, in that case the maximum frictional force which will act, that's value is equal to mu s, that is the coefficient of friction in static, into normal reaction. So normal reaction, we know normal reaction is equal to the reaction given by the ground to the object, okay, we have seen what is normal reaction. So he's saying the multiplication of static coefficient of friction and normal reaction will give the maximum frictional force. You got it? This is the maximum amount of frictional force, not the amount of frictional force. It is the maximum amount of frictional force in the static case. In the next statement he is saying the friction required to start sliding is greater than the friction required for maintaining sliding. See what it is saying. It is saying, suppose there was two surface in contact, okay, this is the surface of the object, this is the irregularities in the object, okay, the upper one, and in the ground this was the roughness in the ground. See, in the initial, there is interlocking between these two surfaces, so the frictional force, whatever frictional force you got, that's okay. After, once there is sliding is happening, what will happen? The irregularities in the ground and the upper one, like in the block, these will not interlock. Once the motion will start, they will just go over the edges of these irregularities, okay, so there will be no interlocking. So in that case, there will be less amount of resistance to this motion, okay. So that's why the friction required to start sliding, is greater than the force required to maintain sliding, okay. These are the 5 important statements regarding law of friction, okay. Now we will see a note, okay, regarding this. I'm writing a note. What it is? See, I'm saying the magnitude and direction of frictional force. See, frictional force opposes relative motion, so the magnitude and direction of frictional force is not constant in static. He's saying the amount of frictional force and the direction is not constant in case of static. Okay. So magnitude and direction of frictional force is not constant in statics, and that's why it's also called the static frictional force. Static frictional force is what it is? It is self adjusting force. What it is? Self adjusting force. See, I was talking about two forces. One force was the force in the direction of possible motion, that is P, okay, or whatever the component of the force along the contact surface, that is the force in the direction of possible motion. So the motion will happen in the direction of that force only, okay. He's saying the frictional force will oppose the motion. So motion, suppose motion in x direction, so the force acting in the possible direction is in x direction. The friction is also tangential to that force. We have seen in the statement the frictional force acts tangential to the contact surface. The force in the direction of possible motion, that is also tangential. Here the frictional force also tangential, but it is opposes the relative motion. So what will happen? It will be collinear to each other, and it will be collinear but opposite direction. So the force in the direction of possible motion and the frictional force, they are collinear to each other. Getting my point? Okay. In that situation, suppose this is the force in the direction of possible motion and acceleration will be in this direction only. In that case, he is saying the frictional force will be in this direction. Magnitude I don't know, but friction will be in this direction. That will be tangential to the contact surface. Okay, here will be the force will be acting. I'm describing above, but actually here is the force component along this line. Okay, this is the force, and here is the frictional force. Okay, here along the contact surface. Getting my point? These are the two forces. These are collinear to each other and opposite in direction. What is the magnitude of friction force? We will see. And he is saying the magnitude and direction of the frictional force. This frictional force is not constant. So we see the static friction maximum value is equal to mu s into n. Okay, this is the maximum value in static. He is saying the magnitude of the direction of frictional force is not constant. Okay, is not constant in static case. What it is? So this thing you should not remember, but you got the idea there that the frictional force tangential to the contact surface. Okay, so it will be like collinear to the force in the direction of possible motion, because that one also in the direction of possible motion, and motion we know always along the contact surface. So we will see, wait a minute. So what is self-adjusting force? That means the static frictional force is a self-adjusting force. That means he is saying the magnitude and direction, these will be adjusted by itself. The magnitude of that force is adjusted by itself. So static frictional force is a self-adjusting force. See, you got all the idea, all the concept. Now I will make you how to calculate the frictional force, value of frictional force. Okay, the law we have got all these 5 statement and the note. These are the 2 statement. Okay, now I'm giving some examples. Okay, see how to calculate the frictional force. Now I'm taking the block. Okay, the same block for different cases I'm taking. See, these are the cases. Okay, now what I'm doing, I'm applying some amount of force for relative motion. Okay, there is contact surface between this. Okay, I'm not, the situation is like this. There is a contact surface and above which there is a block. Okay, placed on it. I'm just drawing the free body diagram of the block. Okay, now this is the force P. Here this is the force P1. Here is the force amount, the force in the direction of possible motion, that is P2. Here is the force P3. In this situation, the weight is WWW. Okay, the weight is W. Here is also weight is W. Here is also weight is W. Now you will get normal reaction N1. Here we will get normal reaction, that is N. Everywhere the weight is same, so normal reaction will be N only. So N. Okay. In this situation, see, this is the amount of force. Are you saying the friction will be, I have discussed that friction will oppose the relative motion. The object is trying to move in this direction only. Okay, in the positive x axis. The relative motion in the positive x axis, so the friction will be in the opposite to the relative motion, so it will be in the negative x axis. So I'm saying the friction will act somewhere here in the along the ground. It's the friction. It will be act tangential to the contact surface and in the opposite direction. See, I'm applying P1. Are you saying this frictional value will be equal to how much? The mu s into n? No, it is not mu s into n, because if it is mu s into n, see, suppose I have a 50 something any amount of weight, I'm getting some normal reaction. Okay, I'm getting some normal reaction, I'm applying the amount of force is P1. Okay, I'm getting the frictional force like this F1. Okay, in this case, is this the value is equal to mu s into n? Not at all. If it is mu s into n, we'll see what will be the amount. But for equilibrium, if we apply the net force in x direction is equal to 0, in the situation, the frictional force value must be equal to the force in the direction of possible motion. Getting my point? So it's saying if you apply in any cases, okay, everywhere there will be some frictional force. There will be some frictional force. All this situation, this is P1, P2 and P3. Okay, in all this situation, here is P3, everywhere you got frictional force is equal to the amount of applied force, but it is amount of applied force up to certain amount. See what I'm saying. I'm saying suppose you got from the law the Fs maximum is equal to mu s into n. You know it is given from the surface, so it is given in the question paper. And the normal reaction, since weight is given, you can calculate the normal reaction. If it is inclined, you will calculate the by resolving the weight into the perpendicular direction, you can calculate normal reaction. In any case, you will be getting some value. Okay, you will get Fs maximum. This is Fs maximum, that is the static maximum, the amount of frictional force which the maximum amount of frictional force which can be possible in static case. But you are applying F, this value have some limit. Okay, here suppose this is, I will say this is suppose 10 Newton. Okay, if you are applying 1 Newton, what will be frictional force in this case? So I'm writing, suppose the P1 is equal to 1. Okay, P1 is equal to 1. I'm writing again, it is Fs maximum. Static friction. We know the Fs maximum in this case, Fs maximum is equal to, it's 10 Newton, I have assumed. Okay, if I'm applying 1, what will be Fs? That is the Fs, the static frictional force. It will be 1, because net force in horizontal direction will be 1. If I'll apply 5, it will be 5. If I'll apply 9, it will be 9. If you'll apply 10, it will be 10. If I'll apply the applied force is 11, what will be the amount of frictional force? It will be 10 only. It cannot go beyond the maximum value of the frictional force. Getting my point? So the frictional force, static frictional force, is equal to the amount of applied force whenever the applied force is less than the Fs maximum. Once the the applied force in the direction of possible motion, this force P1, P2, P3, if all these force value is increased, or we can say the magnitude of these forces, whenever this magnitude is above the Fs maximum, in that case what will happen? The frictional force will be maximum only. Okay, if it is below the, like this 5 Newton, the maximum is 10 Newton, you are applying 5 Newton, in that case you will get same 5 Newton only. Okay, if the force in the direction of possible motion is less than the Fs maximum. I think you got the clarity how to calculate the frictional force. Okay, we'll see whether the object will be in static and in the next slide. But for static, you can apply the, see, this is the same situation. Okay, here was a block, you are applying some 1 Newton, you are getting frictional force 1 Newton, so the magnitude adjusted. You apply 5 Newton, again you got the frictional force as 5 Newton. Okay, here, so the magnitude again adjusted by itself. You apply 9 newton, you got frictional force as 9 newton. You apply 10, the magnitude of frictional force become 9. So up to the maximum limit, what is happening, it is self adjusting. So in the static case, this is self adjusting. Okay, this value, once the force in the direction of possible motion is greater than the amount of maximum frictional force, once the P1 is exceeding this 10 newton, in that case the net, if you apply this condition, net force in x direction is equal to 0. So since the P1 is greater than this 10 newton, in that case there will be a net force. Okay, you don't get the net force x is equal to 0. If you apply net force is equal to only net force in x direction, you will calculate. This is you are getting whenever the force, applied force, is less than fs maximum. So I am simply saying what I am saying, mu kahuchi a block रे जदि जेतिक अमाउंट रो तमे अप्लाई फोर्स करछो इन द डायरेक्शन ऑफ मोशन, एटा जदि वैल्यूडा एफएस मैक्सिमम रु कम अछि ताहले ता वैल्यू एडजस्ट हो जाउछि सेम द फ्रिक्शनल फोर्स वैल्यू केते होछि ना अप्लाइड फोर्स. Once the magnitude of this force is exceeding the fs maximum, in that case you will get the frictional force as fs maximum only. Suppose fs maximum for a given situation is 10 newton, you are applying 11 newton, in that case the maximum frictional force you will get 10 newton only. Are you getting my point? I think you got how to calculate the static frictional force value. Okay, that's why I was saying it's a self adjusting force, because the magnitude of the static force is being adjusted by itself. Okay, and the magnitude and direction of the frictional force is not constant in static. Is saying the magnitude is not constant, we have seen. Why is saying the direction of the frictional force is not constant in static? We'll see. Okay, now you got how to calculate the static frictional force. Now I'm going for the next concept, that is how to check the state of the object. See, we were taking a block and some amount of force was applying on this block. Okay, in this block, what is amount of frictional force in case of static we can calculate. Now we have discussed. Before that, we need to know whether the object is in rest or motion. Okay, see, the question will be like this. There will be a block given and some amount of force will be given, like 10 newton or 15 newton, whatever. You will get some certain amount of weight, that's why you will get normal reaction as well. Now you can calculate fs maximum. Okay, you can calculate fs maximum as mu s will be given and n you can calculate, so you will get certain amount. Okay, once you got fs maximum, you need to check this applied force. Okay, this applied force means p, whether you need to check whether p is less than or equal to mu s into n. That is the limiting friction value, or we can say the maximum value of frictional force in static. If the p is less, the applied force is less than the mu s into n, you will say that the body is at rest. It is at static. It is at static equilibrium. Okay, static equilibrium. If the object in static equilibrium, in that case what will happen? The frictional force will be equal to the applied force. The amount of frictional force we have discussed just, the frictional force will be equal to the applied force. This is the first. If you will see the amount of frictional force, if, okay, these are the condition you need to check. If the applied force is greater than mu s into n, once the applied force is greater than the frictional force, that means whatever resistance was given by that contact surface is become less than the applied force, then there will be motion. So the object will be in dynamic condition. Okay, the object will be in motion. In that case, the value, once the motion is started, I have said the amount of friction required for start of that motion. Okay, this is the force which is required for starting the sliding motion. Okay, because you need to overcome this maximum amount of frictional force in static so that the motion will be possible. Once the motion is start, then what will happen? There will be no interlocking. The blocks will travel above the edge. Okay. So in that case, there will be less amount of frictional force. So there will be reduction. So and once you will getting some motion, you are getting an constant amount of frictional force in the dynamic condition. So Fk, the kinematic friction, okay, kinetic, sorry, not kinematic, it's kinetic or dynamic frictional force is equal to, I will write mu k into n. It was the maximum ms mu s into n, here is mu k into n. Getting my point? So it's a constant value. The frictional force whenever the object in motion, okay, whenever the object is in motion, the frictional force, the dynamic frictional force or kinetic frictional force is mu k into n is a constant value. Okay, it's a constant value, but this one is not constant. This was self adjusting in the static case. Okay, the kinetic case is a constant value. Getting my point? Yes. Now the first thing you need to check the applied force in the direction of possible motion P. You need to check whether this amount is less than mus into n. If it is less, then it's static equilibrium, then the frictional force will be equal to the amount of applied force. If the applied force in the direction of possible motion is greater than the mus into n, then you will say the object is in motion. So in that case, the frictional force will be mu k into n. Getting my point? Now I'm going for, this is called limiting frictional force. That is the fourth statement in the law. Okay, the yes, fourth statement, the maximum amount of frictional force Fs maximum is equal to mu s into n. That is the limiting frictional force or maximum frictional force, the same thing. Or we can say there are a different term used in the question. I will write all these things. It's called limiting friction, or the same thing, it is called sometimes the maximum frictional force in static, because the magnitude of this force, the amount of force is not constant in static, but dynamic the amount of frictional force is mu k into n. That is a constant value, and it is also called the frictional force at impending condition. That means just trying to get the motion start. Okay, so in that case, the amount of friction which will be act, that is also called impending condition frictional force. Okay, or we can say the maximum force for equilibrium. Once the applied force is less than this, there is the object is in equilibrium. Once the applied force in the in the direction of possible motion is exceeding this value, you will get dynamic condition. So this is the maximum value for equilibrium. So this is the maximum value of force for equilibrium, or we can say after just if you just increase this amount of force, okay, if you just increase mu s into n, you will get the object to be in dynamic condition. That means the object will be in motion. So it is also called the minimum force to start the motion. These are all are same statement. Okay, or we can say the minimum force, I'm writing here itself, to start the motion, or it will be written everywhere like the amount of frictional force to just start the motion, These are the same thing. Okay, in the MCQ type question, These like the terms like this will be used. Now we'll go for the range of the frictional value. See the direction. I'm saying this is the block. Okay. If this is the amount of P, then the frictional force in this direction. If you change the P in another case, if you take P in this direction, the same block, then friction will be in this direction. This is the P. Okay. So if you change the direction of the force in the possible direction, the frictional force is changing because the relative motion was in this direction. Here the relative motion in this direction. So the direction is also changing. So the maximum value of static friction, we know Fs maximum was mu s into n. So its value will be from negative direction to positive direction. So the range will be like minus mu s into n up to what? Up to mu s into n. That is the positive one. Okay. This is the range of the frictional force. Or I can say, because it is I'm talking about the static frictional force, so this value was equal to, if the static frictional force, that means this is the maximum value of frictional force in positive direction, it is in negative direction. It is also equal to what? Fs is equal to P in the static case. Whenever the object in static condition, the amount of frictional force is equal to applied force. Though the limit of possible motion P also, the limit is same, mu s into n less than or equal to minus mu s into n, because Fs is equal to P. Okay, this is the range of the frictional force. Now, if I will write, see, graphically I will let you understand the frictional force magnitude. Suppose I am taking, see, this is the applied force I am taking, sorry, this is the applied force P. Okay, this is the amount of frictional force we are getting. So what will happen in this situation? The applied force was 0, the friction force you will get 0, you apply the net force in x direction is equal to 0, equilibrium condition, you will get the same amount. You apply 5 Newton, you will get the 5, here 5, here 5. Okay, you apply 10, you will get 10, so you will get here 10, 10. Then you keep on increasing, you will get certain amount of Fs maximum. For a given condition, you have the Fs maximum as mu s into n. This is the constant value for a given situation. So you suppose this is Fs maximum. Okay, this value is Fs maximum for the situation. If this is Fs maximum, it is going directly, as you are increasing the applied force, the frictional force increasing. So there is a directly proportional. So it's a constant line. Once this force is Fs maximum is reached, what will happen? There will be a dynamic condition will start. So the object will start to move. So in that case, there will be the reduction in the frictional value. That is, before starting of the motion, this is the value Fs maximum which was applied on that object. Once the motion will start, okay, just after the verge of the motion, that means when the motion start, what will happen? There will be reduction in frictional force. There will be some reduction in frictional force, and the frictional force value will be constant throughout the motion. That value will be equal to mu k into n. The kinematic frictional force will be given in the question. Otherwise, in some type, if mu k not given in the question, because the value of mu k and mu s is very close to each other, you can take mu k is nearly equal to mu s. Okay, if not given in the question. So this is the amount of frictional force in kinetic or dynamic case. Here is the static frictional force. This is the friction variation. Okay, this point is the Fs maximum, that is mu s into n. I think you got how the graph I have drawn. Okay, now so you got two things. Fs is equal to P, that is self adjusting, the magnitude and direction is adjusted, and Fk, the kinematic friction, is equal to mu k into n. That's a constant. The direction as well as magnitude both are constant. Okay, these are the two things you have learned. Now we'll talk about what is angle of friction, what is angle of repose, and cone of friction. These are the MCQ type question will be asked here only. So see, angle of friction. What is angle of friction? See, if now I will take an example. Suppose this is a block. Getting my point? In this block, suppose I am drawing the free body diagram of the block. This block is placed somewhere in a ground. So I am applying some amount of weight. Okay, not an issue. I am getting some normal reaction. Okay, not an issue. I am applying some amount of applied force in the direction of possible motion P. Okay, no issue. Then I am getting some frictional force in this direction. Here it will act. Okay, are you getting? This is the F, because see the frictional force, sorry, I will write here only, because see, you cannot change the force like parallelly, you cannot shift, you can slide along its line of action because it's a force. Okay, frictional force I cannot draw over here, so it is acting along the contact surface only. Okay, and this force can be applied time to time. If it is applied here, you will show here. If it is applied in between this point, you will show here. No, the point of application depend upon the situation to situation, but F, the friction is will be applied always at the contact area only, because see, there will be some situation the block without sliding, there will be situation that the block will topple. That means ये क्या होगा, रोटेट हो जाएगा कभी कभी. So in this situation we need to take care of all these things. So this is the self adjusting force. In this case what I am saying, this is the frictional force, this is the normal reaction meeting at this point. Okay, so if I'll find the resultant, okay, if I'll find the resultant of these forces, the resultant will be somewhere like this. By applying F, the resultant of F and N is this, the resultant. This is the resultant. The angle made between these two, that is called angle of friction. So the angle formed between the resultant of frictional force and normal reaction and the normal reaction. So what is R? R is the resultant of frictional force and normal reaction. Okay, the angle between this R and normal reaction is called angle of friction. Are you getting my point? Yes, you got it. What is angle of repose? For understanding angle of repose, I am taking an example. See, I am taking an inclined road. Okay, this is the inclined road over which there is a block. Suppose there is a block. Block like this. In this situation what will happen? The weight is at the center of this block. So in this, that is W. Suppose this angle is theta. So here will be W cos theta. Again you will get some normal reaction. The normal reaction is equal to, see, whenever there will be situation like inclined plane, you just don't take x-axis like this, x and y-axis, horizontal and vertical. You take like this, horizontal, vertical. So once you take this and you can apply the horizontal direction equilibrium condition, vertical direction equilibrium condition, it will be very easy. Okay, in this situation you suppose the applied force in this direction, this is the applied force, that is P. So the friction will be in opposite direction. Getting my point? This will be the frictional force. So I'm saying, to understand this angle of repose, the angle of friction was what? Angle of friction is the resultant of these two. You need to draw the resultant of these two. Okay, this is the resultant. The angle between this resultant and the n called phi, that is the angle of friction. The angle of repose is saying, if you, what will happen, see, if you keep on increasing the theta, what will happen? If you keep on increasing the angle of inclination of this surface, what will happen? You got some amount of angle of friction. If it is exceed, okay, whenever, what will happen, whenever the theta will be greater than this phi, there will be no static, the block will not be in equilibrium, there will be a sliding downward direction. Okay, so automatically, without any without any additional force, you are applying force in upward direction. Once the inclination will be equal to, suppose this force is equal to 0, I'm saying this force is equal to 0 applied force. Okay, if you remove also, the block was in what, the block was in equilibrium. Why it is in equilibrium? Because of the weight component. See, I was showing this one as a different case, now I'm doing some changes. See, I'm just changing the situation, don't worry. See what I'm saying. This was the weight of the block, this was placed on the inclined surface. Okay, I'm not applying any force. Here is the component, another component, which is the W sine theta, which is trying to pull this block in downward direction. Okay, this is the force in the force what, this is the force in the direction of possible motion. You will get friction every over here, okay, in the opposite direction to the possible motion. So once he's saying, once the theta is become more than phi, the phi will be like this. Here is the normal direction, frictional force, so there will be resultant, this is the resultant, and you will get phi here like this. This is the phi. Once this theta, once this theta is will be greater than this phi, there will be sliding. Automatically there will be sliding without any external force due to weight. I'm just talking about weight. See, if you keep on increasing theta, the block will automatically slide down, the block will not be in equilibrium. Getting my point? So angle of repose is saying, as long as the block is in equilibrium, as long as the inclination, once the theta will be greater than phi, it will be sliding. So I'm writing, as long as the inclination of surface is less, or I will write like this. So I'm saying, as long as the inclination of the surface is less than or equal to friction angle, that is phi, as long as the inclination of the surface, that is theta, is less than phi, in that case what will happen? The block will be at rest. This is the condition. So in this situation, he is saying the angle of repose is saying, the angle of repose is nothing but is equal to angle of friction. So small MCQ type question will be asked. See, angle of repose is equal to angle of friction. Okay, when the inclination angle of the surface is less than phi. Okay, in this situation, the angle of repose is equal to angle of friction. Getting my point? So he's saying the theta, the angle of inclination, should be less than the phi, the friction angle, so that the block will not slide automatically on its own. Okay, that is angle of repose. See what is cone of friction. Cone of friction, I'm saying I have a block like this. I'm applying some amount of weight on this. I'm getting some normal reaction over here. I'm applying a force P. I'm getting some friction over here. So I'm getting this is as the resultant of the frictional force and normal reaction. This is R. And here is the angle phi. If what will happen, I will make this as a triangle. Okay, see, this is a triangle in 2D. If I'll rotate this triangle about the axis, this axis or this axis, if I'll rotate this triangle, what will happen? You will get a cone. Getting my point? You will get a cone. This is called cone of friction. What is cone of friction? The cone you are getting by rotating this triangle. Okay, this triangle, what it is? Triangle is representing. This is the value of, in this triangle the value of resultant is possible. Okay, it can see if in this cone, if will be the normal reaction, you cannot change, it's constant. Okay, if you do the applied, if you change the applied force, this, if you change this force, the F will be changed. If you keep on decreasing the frictional force, what will happen? It will keep on, this vector will keep on going back slow. Okay, so what will happen? It will, the magnitude of this force will be reduced. So what will happen? This will be go up like this. What I'm saying, just see, this is the block. Suppose this is the weight, this is the applied force applied, this is the normal reaction you are getting, here is the friction force. So by applying the parallelogram law, the first chapter I have said the finding the resultant, this is like this. Okay, this is the resultant force, this is the resultant force. If you decrease this F, suppose this was the F, magnitude of the F, now you are just reducing to over here. So what will happen? The normal reaction will be somewhere here, the resultant will be like this, the resultant will keep on going up. Okay, if you reduce the frictional value up to here, again the resultant will be going here. Are you getting my point? So this triangle, suppose this is the Fs maximum and N. So you are getting the resultant of this. Getting my point? So he's saying the cone of friction, you are getting the region, in this region the value of resultant is possible. Okay, this is called cone of friction. In the cone of friction, he's saying the value of resultant of N and F is possible in the triangle, and if you rotate this triangle, you will get a cone. Okay, that's called cone of friction. So almost we have covered the concept of all. Now I just need to discuss in detail the angle of friction. Okay, what it is angle of friction? See, I'm saying this is phi, this is the resultant of F and N. Now if I will write resultant is equal to F square plus N square. Is there any issue? Not at all, because this is the resultant of F and N I'm finding by the formula. Now see, I'm writing tan phi. Tan phi, how much? This is the phi, so this will be the perpendicular. Okay, so perpendicular is nothing but F is equal to F divided by, this is the base, that is N. So phi, the angle of friction, is equal to tan inverse F by N. This is the value of the angle of friction. Getting my point? Now I am writing, suppose Fs maximum is equal to mu s into N. So in this, from this equation I can write N, F mu s is equal to how much? mu s is equal to fs maximum divided by n. Here is f by n. I'm talking about mu s. Okay. So tan phi is equal to f by n, but mu s is equal to fs maximum by n. If you will take impending condition, this f will be f maximum. In that case, what will happen? I will write. Can you see? If I'm taking limiting condition, see angle of friction value we calculated like this. The phi is equal to tan inverse f by n, the frictional force by n. For limiting condition, we know the friction value will be like this. Fs will be fs maximum mu s into n. So the phi is nothing but how much? The tan phi is equal to fs maximum by n. We know the fs maximum by n is equal to mu. So for the limiting condition, I'm getting tan phi is equal to mu. Okay, for limiting condition, tan phi is equal to mu. You should remember this one. Okay. So from here, angle of friction is equal to tan inverse mu. For which case? The condition you should remember must. It's for limiting case. For limiting case. Okay, for impending case. In that situation only we have derived. The mu is equal to tan phi, or we can say phi, the angle of friction is equal to tan inverse mu s. Mu s, okay. Mu s. Mu s. So this is all about angle of friction. Okay, we got the what is angle of friction? The angle between the resultant of f and n and normal direction. Angle of repose. The angle of repose is equal to angle of friction as long as the inclination of the surface, that is theta, is less than phi. The block will be at rest. In this situation, he is saying at equilibrium only the maximum value of theta. Okay, as long as theta is less than phi, the block will be at rest. In this situation, we will say angle of repose is equal to angle of friction. Now we will proceed for the next concept, that is the slipping and toppling. See, sliding and toppling, these are the two things. Suppose I am saying the motion. How do you think the motion can be possible in an object? See, this is a block. This is placed somewhere over here. I'm just not taking this object. I will be changing the object. Rather, I will take an object which is like squarish type. Okay. Okay, this is the object. In this, I will apply the same thing. Here is the applied force P. It has certain weight W. For that, you are getting some normal reaction N. Again, you are getting some frictional force F. In this situation, I am saying what will happen? You need to check what? For sliding, you need to check what? If P is less than or equal to mu s into n, it will be in static. If P is greater than mu s into n, then it will be in motion. We know for static, the frictional force is equal to P. For motion, frictional force K is equal to mu K into n. We have discussed all these things. One more thing, there is two motion. If I am talking about motion, it's not just sliding motion will happen. There is two things can happen. Motion means sliding can also happen, or toppling can also be happen. Without sliding, there is possibility. Suppose, see, the situation is like this. This is a block which is placed over this surface. This is the case. Okay, in this you are having some weight. You are again getting some normal reaction. You are applying some force, suppose in this direction. Okay, I'm applying these forces like this. So you will get what? You will resolve this force. This is the component, horizontal component. This is the vertical component. Suppose this is theta, you got p cos theta, you got p sin theta. What will happen? See, here will be the frictional force. There will be situation if you calculate moment about this point. What will happen? If you calculate moment about this point, see, if these two are equal, weight is equal to normal reaction. We know these two are equal. The moment about this point due to this force and this force will cancel out. The force is same, the distance between them is also perpendicular distance between them is same. So n into this perpendicular distance and in the which direction? In this direction, that is counterclockwise positive. Here will be clockwise negative due to the weight. The moment due to these two will be cancelled out. Again, the frictional force, will it give any moment about this point? No, it will not given. It will not given any amount of moment about this point. Suppose this point called O point. Okay, is this force, I have replacing this force with the component, so is p sin theta is going to give any moment about this point? No, the line of action is passing through, so there will be moment will be p cos theta into the vertical height. Okay, so the moment will be equal to, net moment will be equal to how much? P cos theta into, suppose this height is y, okay, the vertical height into y is equal to net moment. If the net moment is not equal to 0, okay, you calculate net moment. If net moment is not equal to 0, in that case what will happen? There will be toppling. The block will topple about this point. Getting my point? If net moment is equal to 0 about any point you take, then what will happen? There will be no toppling. So there is two conditions: the block can topple as well as slide. So these are the, I can calculate the F minimum amount of force required for toppling, minimum amount of force for sliding. This thing we can calculate. If you want, I can calculate, no issue. But you don't need for ATO, okay? Because we have read the concept of all the magnitude, force, moment, all these things I can derive in a 5 minute. No need to worry. So let's derive it. Suppose in a condition it is asked for calculating the minimum force. Okay, minimum force to make a block move, to move a block. So it's just talking about minimum amount of force for moving a block. Suppose this is the object. I'm drawing three situations. See, these are all are the same situation. I'm giving you a single force. Suppose I have given the force P. You apply in any direction. So how the force, there will be minimum amount of force, in which case there will be minimum force required to move the block. See how I will apply the force P so that there will be requirement of minimum force. Suppose I'll apply like this. Again I will like this. Again I will apply like this. These are the three conditions I'm saying. I'll apply the force like this. What will happen? These are all P, P, P. I need minimum force for moving a block. So F minimum means the frictional force, Fs maximum, the maximum force that must be reduced. How that will be reduced? It is equal to mu s into n. So you cannot change mu s, so you need to reduce n. If the normal reaction value is less, then only the Fs maximum will be less. So if P applied in this direction, so here is W, this one will be n. No, there will be no changes. Here it will be P cos theta. Suppose this is theta. Again this will be P sin theta. So here will be W. So normal reaction will be is equal to, in the downward direction, W minus P sin theta. How am I calculating this N is equal to? By applying net force in vertical direction is equal to 0. If you here see here, that will be P cos theta, here will be P sin theta. So if W is in downward direction, normal reaction will be in upward direction. Normal reaction will be equal to W plus P sin theta. So W plus something, that means the value is increasing. Here W minus P sin theta, the value of normal reaction is reducing. So this is the best, the second one, this is the best situation to apply the force in the inclined upward direction, so that there will be reduction in Fs maximum. Okay, so for minimum force to move a block, N will minimum when the P is inclined upward. Getting my point? So we need to apply the force in inclined upward direction. Now I need to calculate the minimum amount of force for moving a block. Now I'm taking a block. This is the block. Okay. In this block I apply the force P. Okay. Here is the P cos theta. You got P sin theta. Over here you got P cos theta. Here is W. The weight. You got normal reaction. Again you got friction. So N is equal to how much? N is equal to W minus P sin theta. Okay, this is the normal reaction. If you apply net force in horizontal direction is equal to 0, so F will be equal to, the friction force is equal to mu s into N. N is equal to W minus P sin theta. Okay, how the frictional force is equal to how much? The frictional force is equal to P cos theta if the block is in equilibrium. Okay, so I'll write like this: P cos theta. I'll write P sin theta to the other side, so it is P cos theta plus P sin theta is equal to mu s into W. Okay, now from here P is equal to mu s W divided by cos theta. See here it is multiplied with the normal reaction, so it is sin theta. So it is mu is multiplied here, so plus mu sin theta. This is the force. Okay, you want the minimum force. How we will calculate the minimum force? For that we need to take derivative of this force with respect to theta. So once denominator will be increased, so the P will be minimum. Okay, so I can take the denominator. To maximize this denominator, I need to take the derivative of this one. Like I will take d by d theta of cos theta plus mu sin theta. Because to decrease the value of any fraction, you need to increase the numerator or decrease the denominator. Okay, we cannot change this one, mu s into W, so we need to maximize this because we can change the theta. So in this case cos theta derivative will be minus sin theta plus, sorry, you just need to take this derivative is equal to 0. From here you got minus sin theta plus mu cos theta is equal to 0. From here you are getting mu is equal to sin theta by cos theta is equal to tan theta. So you are getting how much? Tan theta is equal to mu. In the initial we have seen, here we got the value tan theta, tan phi is equal to mu s. So if I compare this one with this, tan theta is equal to mu, and now I'm comparing with for limiting case. Okay, for limiting case, if I'll take mu is, mu is equal to how much? Tan phi. So from these two, from this one and this one, I can write theta is equal to phi. So this is theta, angle of inclination of the force. You can apply it in inclinedly upward direction at an angle theta, and that theta is equal to phi. That must be equal to phi. Okay, so you got limiting case. So for minimum force for moving a block, if you want to move a block with minimum force, you just remember from this slide, you don't need to remember all these things. You just need to remember the force must be inclined upward. The second thing is that the force, inclination of the force must be equal to phi. The inclination of this is inclination of force must be equal to angle of friction phi. Getting my point? Once for the limiting case, you put in this equation P is equal to mu s. In this equation, if you put mu s is equal to tan phi, you again get F minimum value. No need to calculate all these things. If you just put mu is equal to tan theta, it will be mu is equal to tan theta, that is sin theta by cos theta. So sin square theta cos square theta, again it will be the denominator, cos theta will be going to up. Again you have mu s, so it is sin theta by cos theta, so you will be only having mu sin theta. So F minimum, if I'll write like this, see, you got tan theta is equal to mu, the P force you have calculated, mu s into W divided by cos theta plus sin theta into mu. If you put tan theta, mu s is equal to tan theta, directly I am writing sin theta by cos theta into W. Here is cos theta plus sin theta. Mu s is equal to tan theta, that is sin theta by cos theta. Taking a less LCM in the numerator, you will get like this. It will be cos theta, it will be cos square theta plus sin square theta, which is equal to 1. In the denominator, you have sin theta by cos theta into W. So it will be equal to sin theta into cos theta into W in numerator. This value is equal to 1, so it will be multiplied in the numerator, that is cos theta. So it will be cancelled out. So F minimum is equal to W sin theta, or we can say W sin phi, because theta is equal to phi. Getting my point? So you got F minimum is like this. You can remember if short question can come, otherwise you just skip this slide, two slide, this one, this one, this one, this one. Okay, again for toppling you just need to do like this, the moment calculation. Okay, the moment about this point you will calculate moment, you got like this. Okay, whatever value will be, you will be getting toppling. So these are the thing possible. Now we'll go to very important. So the last toppling sliding you can skip that one, but this is the very important one, the belt friction and the ladder friction. These are the two things. See, belt friction is saying whenever you have a pulley, okay, whenever you have a pulley like this and you need to apply, you have a rope, okay, this situation like this. In this case you need to calculate this one. This is called angle of contact of the rope with the pulley. Okay, this is the theta. Suppose this is the rope having tension T1 is T2. If T1 is greater than T2, so it is tighter. Okay, the larger one. This is the slack side. This is the slack side. This is the tight side. So belt friction directly saying tight side tension T1 divided by slack side tension T2 is equal to e to the power mu theta. Getting my point? This is saying simply this is belt friction, and most important thing is that this theta is in radian. If you just put 90 degree 10 degree, you will be having a wrong answer. So theta is equal to in radian, you know, 180 degree is equal to pi radian. Likewise you can convert. Okay, if there is 90 degree, you will write pi by 2 radian. Okay, you just need to put here theta. You will get T1 T2 relation between one tension will be given, other tension will be asked. You will be given mu value, theta value, all these things will be given. You just need to put in this formula, you will get. If like it will be mentioned like 2 round, so 2 round means 2 round, it is the rope is already 2 round plus this angle, so it will be 2 round means 360 degree 2 times. So 2 pi is the 360 degree into 2. So you are already having 4 pi plus this theta. Okay, whatever amount of angle, the angle calculation is very important. The number of turn, okay, which is rotated about this pulley. So this is the best formula for short question. You can have situation like this also. There is a belt drive pulley system. Okay, here is the angle, again this one. So in this case, what is angle of theta? You just see, this is the angle of contact starting here. So this is the angle, it's 180 degree. So theta will be pi in this situation. This is T1 T2. If this is greater, then you can calculate the slack side as well. If slack side is given, you can calculate the tight side. So tight side tension by slack side is equal to e to the power mu theta. Okay, if you take logarithm of both the side, if calculator not allowed, you will take log. So you will get what? Log T1 by T2 is equal to e to the power mu theta. Okay, you can calculate e value, you know, e value is equal to 2.71. In the last previous year question, there was a numerical related to this question also. This is the simple formula. Tight side by slack side is equal to e to the power mu theta. Now we will go for ladder friction. See, for the stability, this is the ladder. Suppose this is a, these are the surface. Okay, one is horizontal, other one is vertical. So here I am placing a ladder. This is the ladder. So in this situation, what will happen? For the stability means for equilibrium, we need, here is the W applied on this. Okay, for stability, what you need, the ground surface must be rough. The ground, this is the wall, the ground must be rough. If it is not rough, then it will automatically slide down. So you need, the condition is must that the ground must be rough. Then you just need to draw the free body diagram of ladder, and by applying equilibrium equation, you can do all the calculation like this. See, this is W, here is the point, so you will get a normal reaction over here. Again you will get a friction. In which direction? If it is trying to go in downward, so the possible motion will be in this direction. So this will be the friction. Here will be a normal reaction again from the wall. Suppose this is the point A, this is the point B. So you getting normal reaction at point B, you getting normal reaction at point A. If it is going down, if the wall is rough, again you will have a, which one? You will have another friction. If it is going down, then friction will be upward. If it is given the wall is smooth, then there will be no friction. By taking these thing A, B, you can apply net force in x direction is equal to 0, net force in y direction is equal to 0, net moment about any point is equal to 0. By taking all these things, you can calculate whatever unknown force is out of these forces, Whatever force is asked, you can answer this question. Okay, this is the ladder friction. In the ladder friction, you should remember this is the angle of the ladder. Okay, that is the theta. As theta increases, what will happen? The stability of the ladder will increase. You just remember this much. Okay, this is all about all the concept related to friction. Now we'll do some numerical. See, read this question carefully. It is mentioned which of the following correctly represent the relation between the applied force and the frictional force developed when the block shown in state state of rest. That means he's talking about static condition. We know for static condition the frictional force is equal to P. This is the self-adjusting force. Okay, if you apply like P, here is F. If you apply, suppose F maximum, Fs maximum, Fs maximum is equal to 10 Newton. If you apply 2 Newton, it will be 2 Newton. If you apply 5 Newton, it will be 5 Newton. If you apply 10, it will be 10. If you apply 11 Newton, again also it will be 10 Newton only. You cannot increase after 10 Newton. So it is keep on directly increasing in the static condition. Up to this is the static condition. Once P will be greater than mu s into n, it will be dynamic condition. Getting my point? So in this case, this one will be our answer. Which one? This one will be our answer. It is keep on increasing. Okay, you apply some amount of force, you got the same frictional force. You apply here force, you got the same amount. You apply here, you got the same. Okay, this is a directly a question. This statement, read this statement. Two metal container rest on the floor as shown in are tied to each other by a massless horizontal rope. Here is a rope given. Okay, these are tied each other. What is the magnitude of maximum force P in Newton that can be applied without causing both the two container to move? Without move is talking about the static condition. The coefficient of static friction between the floor and the container A and B are 0.5, 0.3. So between A and B, so between the floor of A is 0.25, it is given. Between B and the ground is 0.3. He is talking about what it is asked. What is the magnitude of maximum force P? Okay, maximum force P is talking about. So you know, in static, F is equal to P. Fs maximum is equal to mu s into n. He is talking about P maximum. How much will be P maximum for equilibrium? For equilibrium. So P maximum will be in a direction and Fs max will be in the opposite direction to P maximum. These two must be equal to each other. Okay, is simply saying you just need to calculate P maximum. See, here is the P. I will resolve it to P cos theta. This one is equal to P sin theta. Okay, no issue. So in the block A, I will draw the free body diagram of block A. See, I just isolate this A, block number A. It is having weight is equal to 10 into G. G is 9.81. I'm taking as 10. So 10. So it's 100. Okay, no issue. Normal reaction you got N is equal to 100. Again you having a force P. How much force P? It is not mentioned. Okay. So this is the force P. If you just resolve it to, you got P cos theta. Again you got P sin theta. P sin theta. P cos theta. So N is not equal to 100 Newton. This is N is equal to 100 plus P sin theta. Okay, this is the case. And here again you have one tension in the rope T. Suppose this is the tension at point A. Tension at this point is equal to towards other end. Here the tension is towards other end. Okay, T equal tension in the row. Always tension is same everywhere. So in this block, this will be the frictional force will be acting. So this is Fa, friction in A. Okay, now I draw the free body diagram of block B. Here is 15 into 10 is 150 Newton. Normal reaction is equal to 150 Newton. Here is the tension, okay, which is trying to move in this direction, the block B. Here will be the friction, Fb, which is equal to nothing but mu s, that is 0.3. This one is 150 Newton, okay, 150 Newton, 0.3 into 150. So it's nearly 45 Newton. Getting my points? So I will apply net force in horizontal direction is equal to 0. So tension is equal to, you will get 45 Newton. So this tension is 45 Newton. So here tension is also 45 Newton. You got? So in this, if we will apply net force in horizontal direction is equal to 0, here is the horizontal force P cos theta. Okay, theta given 60 degree. So P cos theta in this direction will be equal to this direction force. So P cos theta will be equal to tension plus Fa. Fa how much? Mu s, that is 0.25 into N. N is equal to 100 plus P sin theta. 100 plus P sin theta. So from here I can write P cos 60 degree means 1 by 2 minus P sin 60 degree root 3 by 2 is equal to T is equal to 45 degree, 45 Newton plus 0.5, 25% of 100, that is 25. So it's equal to 25. So 45 plus 25, 70, implies P in common. So it is nearly 1 minus root 3 is equal to 2 times 70, 140. So P is equal to 140 divided by 1 minus root 3. Whatever answer will be, you can calculate. Okay, in this way, this type of question will be solved. You just go through the concept, the procedure. Answer can be wrong or right. You can manage it. Okay, it's depend upon your calculation. So again, see this question. So we'll draw first do the short question, then we'll try to do this type of question, long question. Okay. So here the short question. See, which of the following statement is correct? The rolling friction is greater than sliding friction. I have not talked about rolling friction. So now I will talk about what is rolling friction. See, rolling friction. The friction on the object, on this object we have discussed. Okay. Here is the rolling object. Okay, roller, like a wheel or a disc, anything. This is the rolling. In this situation, what amount of friction will be act? So now I'm taking a roller. Okay, this is the roller. This is the ground. Here is the weight. You will get some normal reaction. You apply some amount of force in this direction. Okay, if you apply this amount of force, it will translate. So for roller, the moment are required. Okay, not force. You need a moment. Okay, suppose this is the moment acting on this roller, so that it will rotate in this sense, that is clockwise sense. So if I'll draw the free body diagram of this roller, what is happening? See, since it is moving in this sense, clockwise sense, it is moving in this sense, so this is moving in the upward direction, it is going like this. Okay, so in this sense the friction will be in this direction. Okay, for rolling friction, you know, friction means opposes relative motion, opposes a relative motion. So the motion of this point is in this direction, the motion. So friction of the rolling will be like this. Okay, so the friction force in rolling is equal to nothing but mu r, the rolling friction coefficient, divided by r into n. So why am I writing mu r by r? See, the rolling friction coefficient of rolling friction, coefficient of rolling friction having the unit mu r, having a unit is equal to meter. Okay, so you need to make it with unitless. So how will be doing this? By dividing the radius. Okay, and the radius of the wheel, this is the radius of the wheel, r. So in this situation, this is the coefficient mu s, this is mu into n. Okay, so this is the formula for calculating rolling friction. Why it is like this? Because see, in the sliding there is a contact area, big contact area. Here you can see the contact area is a point. In 3D this point will be like a line, so there is less contact area. Okay, I was saying friction is independent of contact area. Okay, no issue at all, whether it's a big or a small, it does not matter. Here its sliding motion was happening, interlocking is happening. Here there is no interlocking, so it is a line. Okay, so the mu r here is very less than the static mu s or mu k, whatever. The value of the rolling coefficient of friction is very less compared to the static coefficient of static friction or coefficient of kinematic friction. Okay, so the rolling friction is also less than friction in static, or we can say friction in rolling. So but we know f static, friction in static, maximum friction in static is always greater than f kinetic. Okay, we have already known this point, but here I'm getting f rolling is less than static and rolling. So I can write for rolling friction, okay, I can write a statement like this: f rolling is less than f kinetic is less than f static. Getting my point? The formula is this: mu into the coefficient of friction into normal reaction. But since the rolling friction having an unit of meter given in the question, you just need to divide the radius. Okay, so this is all about rolling friction. Now we'll go to the question. Which one of the following statements is correct? He's saying rolling is what it is saying. The rolling friction is greater than sliding. Rolling friction greater than sliding, not at all, wrong statement. The rolling friction is less than sliding friction. Yes, it is. Rolling friction is equal to sliding friction, not wrong. So second statement is correct. In this, passenger pulls the emergency brake lever inside a moving train. What type of force is primarily responsible for bringing the train to stop? Train was moving, so there was some movement in the train wheel. So after applying the brake is like this. You apply brake. So you apply the brake, what will happen? It will be come to rest. How it will be come to rest? So see the statement, what is it is asked. The kinetic friction between the wheel and the track is asking what type of force is primarily responsible for bringing the train to stop. Kinetic friction between the wheel and track, wheel or track with the kinetic friction, or we can say the centrifugal force exerted by the emergency. Centrifugal force, no. Gravitational force, no. So due to the friction between these two, okay, the brake and this ground, the wheel and ground, this train come to rest. So the number one will be the correct answer. So this is one the rolling. Here is the kinetic friction between the wheels and the track. Again, the question 12. Which of the following statement are correct? The frictional force always the motion of an object. Yes, it opposes. The magnitude of the frictional force depends upon the area surface area of contact between the objects. It's false. It is independent of the area. It opposes the relative motion. So next we'll go. See, these are the question. Here is the question: relation between angle of friction and angle of repose. We know angle of friction is equal to angle of repose. This is the inclination of the surface such that the object which is placed on the inclined plane will be in equilibrium. As long as it is at rest, the theta maximum value of theta will be equal to the angle of repose. So this one is the correct answer. Angle of friction is equal to angle of repose. Consider the following statement. Kinetic friction is always less than the rolling friction. He is saying Fk is less than Fr. It's false. Second statement, the kinetic friction is always equal to rolling friction. Fk is equal to F rolling. It's also false. Kinetic friction is always greater than the rolling. Fk rolling friction, kinetic friction is greater than F rolling. Yes, it's correct. So statement 3 is correct. Which of the following option is correct about the wheel of the car moving? Wheel means rolling. In this situation, rolling friction is greater, not at all. Static friction is greater than kinetic friction. Kinetic friction is greater than rolling friction. So statement 2 is correct. See this question. What is the magnitude of the moment? He is talking about moment magnitude in Newton meter required to be applied on the cylinder of radius 2 meter, weight 150 Newton, such that it is in the state of impending motion. Impending motion means at the verge of motion. So the coefficient of static friction is 0.25. See what it is given. It is here mu is given 0.25. It is not given having no unit. Okay, no unit. So since it is rolling, still the no unit of the coefficient of friction given. So the formula of this rolling friction will be mu into n, not mu by r into n. Okay, it is simply mu into n because no unit is given. So in this case, he is talking about what is given. The weight is given 150 Newton. Okay, this is the smooth wall. This is the rough wall. You will get a normal reaction is equal to 150 Newton. Okay, he is saying radius is equal to 2 meter. So if I will draw the free body diagram of this roller, okay, I am drawing the free body diagram of the roller. Yes, what are the force? Here is the weight, here is the normal reaction is equal to 150 Newton. He is saying this is the moment applied. Why it is applying? And since this is in the clockwise direction, this point is moving in this direction. So the friction will be in the opposite direction. This is the friction force. So I can calculate for impending condition, the friction is equal to mu s, that is 0.25 into n is equal to 150. So it's nearly equal to 37.5 Newton. Okay, you got 37.5 Newton. 37.5 Newton. You got radius is equal to how much? 2 meter. So the moment is equal to force into perpendicular distance. The radius is perpendicular to this frictional force. So it's radius 2 into 37.5. So it's nearly about to 75 Newton meter. Okay, this is the type of answer. Easily you can do the numerical like this. So see this question, a block of 10 kg rests on a horizontal floor. The acceleration due to gravity 9.81. The coefficient of static friction between the floor and the block is 0.2. Here is the coefficient given 0.2. A horizontal force of 10 Newton is applied on the block. Okay, this is 10 Newton. As shown in the figure, the magnitude of frictional force in Newton of the block. See, he is talking about friction. How much? You just don't know. whether the block is in static or not. You just calculate mu s into n, that is Fs maximum is equal to how much? Mu s, that is 0.2 into n is equal to, here is the 10 into 9.81, I'm just taking as 100. Okay, so 100 newton, so 100, so you will get like 20 newton. So this is maximum 20 newton, so it is nearly high, so applied force is equal to 10 newton, so you will get friction force is equal to 10 newton only, you will not get 20 newton. Okay, so it's not 18 newton, it's nearly 10 newton. Okay, so this is the type of question will be asked in friction. Here is another question. A block is of negligible mass rest on a surface that is inclined at 30-degree horizontal plane as shown in the figure. The vertical force 900 newton and a horizontal force of 700 newton are applied. The block is just about to slide. Just about to slide means impending condition, impending or limiting condition. The coefficient of static friction between the block and the surface is talking about. She is talking about mu value. These are the force applied on this block. So I will draw the free body diagram of this block. This is the free body diagram of this block like this. Is talking about this in this surface, what is the mu value. So here is the force applied like this is 750 newton. Here is the force applied 900 newton. Here will be a reaction force by the inclined surface, that will be the normal reaction. Okay, that is theta. Okay, now see, this is the three force system, so for equilibrium this must be concurrent. Okay, so in the concurrent Lami's theorem, see, I have not mentioned in the Lami's theorem, all must be, all force जो PQR थिला, all force must outward or inward. Here all the force are inward, so this is like this. This is 750. Here this one is 900. This one is the normal reaction. How much? This angle is 30 degree. Okay, this angle is 30 degree. So this angle, this is 30 degree. So this is 30 degree. This is 60 degree. So you are getting as this is 60 degree. So this is also 60 degree. Getting my point? So you can apply Lami's theorem. You can calculate n value. N divided by n. So I will draw neatly this Lami's theorem diagram. See, these are the forces. 750. This one is 900. Sorry, 900. This one is the n. Here is the angle given as 30 degree. So this one will be 30 degree. This will be 60 degree. This one is 90 degree. This one is 90 degree. So I will write the equation Lami's theorem, n divided by this angle sin 90 degree is equal to 900 divided by this angle 90 plus how much? This is 30 sin 30 plus 99, 120 degree. So from here you can calculate n. Once n is known, Fs maximum is equal to mu s into n. Okay, so you just need Fs value, Fs maximum. I will calculate by just, this is the force coming in this direction downward. I will resolve into like this. Here will be a component and perpendicular to this one. I will resolve this 900 Newton. This force will be resolved like this, perpendicular and along. Okay. So by resolving all these, I will be using x axis like this, y axis like this. So I'll apply net force in x direction is equal to 0. From there I can calculate F. Okay, so it will go down. This is the motion direction, so the friction will be in upward direction. Okay, so friction force I can calculate from using equilibrium equation. Then we'll put here Fs maximum, n is known, mu s can be calculated over here. So we'll go for next question. A truck accelerate up to 10-degree incline with a crate 100 kg. Value of static coefficient of friction between the crate and the truck is 0.3. Maximum value of acceleration of the truck that crate does not slide. He's talking. This is a dynamic plus friction. Okay, here's what it is saying. There is an inclined road over which there is a truck. Okay, this is the truck surface. This is the truck surface. Again he's saying there is a block, crate is placed on this one. Okay, he's saying, suppose I was saying in the pre-body diagram, for applying equilibrium for applying equilibrium on dynamic of body, for equilibrium on dynamic body you should add inertia force. Inertia force whose magnitude is equal to ma. So inertia force we'll discuss in the dynamics. Inertia force having magnitude is equal to ma, direction is equal to opposite to the acceleration. Force has three characteristics: magnitude, direction, point of application at the center of gravity. Getting my point? So this is the center of gravity. Suppose this is going up. Okay, here the truck with inclination 10-degree, crates of 100 Newton is this is the 100 kg, so 1000 Newton, nearly 1000 Newton is the weight. Static coefficient of friction between the truck and here is the, in these two surface, mu is 0.3. The maximum value of acceleration of the truck that crates does not slide. A maximum is asking. So inertia force will be in this direction, that is M A. Getting my point? This is the force you just need to calculate, add on this free body diagram. Then equilibrium condition will be applied and all the things you can calculate. See, I will do this problem. Now free body diagram. Here is accelerating the W. This will be W cos theta. This one is 1000. This one will be 1000 cos 10-degree. This will be 1000 sin 10-degree. I'm just giving you the step how to solve. This is mass into acceleration. Mass is 100 into acceleration. Since the block is going up, acceleration in upward direction, the friction will be in this direction only. Friction in this direction is saying it is dynamic condition. The block is accelerating means dynamic condition. In dynamic condition, friction is equal to mu k into n. So it is not mentioned whether it is static or direct mu given. So you can calculate from n. N is how much? N is equal to this one n. So here you will get component of the weight, again you will get normal reaction. So from here F can be calculated by putting equilibrium. Suppose this is the x-axis, this is the y-axis. Net force in x-axis is equal to 0. By putting this condition of equilibrium, you will write in the upward direction which force is acting. No force is acting. Okay, so sorry, no force is given, so automatically, so acceleration given is downward direction. So this one, inertia force in upward direction, friction is also in upward direction. This is ma. Okay, so I'll write ma 100 ma plus the friction, you can calculate friction, is equal to downward direction, that is 1000 sine 10 degree. From here you can calculate a easily. Okay, this is the way to solve. So here is a block, 1 kg block is resting on the surface, coefficient of friction is 0.1, a force of 0.8 Newton is applied to the block as shown in the figure. Here is the force applied. Okay, its mass is 0.1 kg. So the frictional force is talking. See, you just need to check whether the block is in static or not. Fs maximum you first need to calculate. Mu s into n. N is equal to 1 kg, so I am taking just as 10 Newton, nearly 10 Newton. So normal reaction is equal to 10 Newton is the normal reaction. So mu is equal to 0.1 into 10. So it's nearly 1 Newton. So the applied force here P is equal to given 0.8, which is less than mu s into n. That implies its static condition. So the frictional force is equal to P is equal to 0.8. That will be the answer. In the next question, a block weight 981 Newton is resting on a horizontal surface. The coefficient of friction between the block and the horizontal surface is given. The vertical cable attached to the block provides a partial support as shown. A man can pull the horizontal force. See, I have not mentioned the diagram, so we'll draw. A man can pull the horizontal with the force of 100 Newton. What will be the tension in T in the cable if the man is just able to move the block to the right? Is saying a block weight 981 Newton is resting on a horizontal surface. Okay, here is a horizontal surface, there is a block whose weight is equal to 981 Newton. Okay, then the coefficient of friction between the block and horizontal mu is equal to 0.2 given. Okay, a vertical cable is attached to the block. Okay, there is a cable, so the tension T in the cable, it provides partial support. Okay, no issue. A man can pull horizontal force with a force of P, it can apply 100 Newton. So what will be the tension? Is talking about what will be the tension when the man is just about to move the block. That means it's talking at the verge of motion or at the impending condition, what will be the tension. So see, the normal reaction will be simply 981 minus tension. By applying net force in vertical direction is equal to 0. Okay, normal reaction is this. Then I can get, this is the P. So at the verge of equation, the whatever friction force you will get, that will be balanced by P. So F friction force you are getting 100 Newton. That is nothing but Fs maximum at the verge of motion. So mu s into n is equal to 100 Newton. Mu s is given as 0.2. So n, you can calculate n from here. N is equal to 100 divided by 0.2. So it's 500 Newton. So putting 500 here, it's 981 minus T. From here, T is equal to 481. Answer. Okay, here is the answer. Here is a block, a box of weight 1000 Newton is placed on the ground. The coefficient of friction between the box and the ground is 0.5. The box is pulled by 100 Newton horizontal force. The frictional force developed between the box and the ground at the impending motion at the limiting condition. What it is asking, a box is there. Yes, it is a box whose weight is 1000 Newton. Okay, no issue. The coefficient of friction between the box and the ground is 0.5. He is saying mu is equal to 0.5, not an issue. When the box is pulled at 100 Newton horizontal force, here is a 100 Newton P applied on that box. The frictional force developed between the box and the ground, Fs maximum, will be equal to mu s into n, that is nothing but mu s 0.5 into n is 1000, so 500 Newton is the answer. Getting my point? These are the question we have discussed. So we have discussed all this question of MCQ. Yes, we have seen the rolling fiction. Then this that the question. Thank you for watching. In the next video, we'll try to cover other topics as well. Thank you for watching.